Hello everyone, welcome back to BC Calc for lesson number 25. We're in our last video where we're going to talk more about slope fields. In this video, we're just going to show you pretty simplistically how to figure out which slope field matches the differential equation that you see up here. So I'm going to give you guys a couple of strategies, and then we're going to do one quick example of that same concept, and we'll be done. So question example 7 says match the slope field with their differential equation. So one of the things that I want you guys to notice is that there's definitely a lot of strategies that we can do in solving this pretty straightforward. So I'm going to start really quickly with this example right here. So dy dx equals y. So notice that we only have y's in our actual differential equation. So x is not affected at all. So x is a independent variable here. So when y equals 0, then my derivative is going to be equal to 0. When y is just a positive number, all right, we don't care 1, 2, 3, 4. When y is a positive number, dy is going to be positive. When y is a negative number, then dy dx is going to be a negative value. So let's look over at these problems and notice that. Look at D. So when y equals 0, then my slope is going to be 0. So again, they sometimes don't show that, but we know it's a horizontal line. When y equals 1, all of my slopes are the same thing, right? Because x is not affected. X is not affected. When y equals 2 and 3, we're getting steeper and steeper, but they're all positive. So all these values here are positive. When y equals -1, we now have a negative slope of -1. Then this is -2 and this is -3. And again, notice that they're all the same value, right? Horizontally. So we know this is going to be D. So another thing to think about here is that when your slope field only has y's in it, just y's, then you're going to have the same values every time you see something horizontal. So everywhere you have horizontal. So when it's just y's, you're going to have the same thing on your horizontals. So now that I've said that, let's look at example right here. 1/2 x plus 1. Now you already know, based on the conversation we just had, you know this answer is going to be B, right? It's going to be B. Because again, whenever you have just x's, then all of your verticals are going to be the same. Now, what we could have also done, let's say we have two functions. Let's say we had two functions, do differential equations, where we have just x's. All right, so how do we know this is the right one? Well, one of the things that I'm going to strongly suggest you guys do, and we're going to actually talk about that now, B, I'm doing a leadway here, is what happens when dy dx is equal to 0? What value of x makes this function 0, right? So then I would have to move the 1 over and become -1, and I get 1/2 x, multiply by 2, and I get x equals -2. So when x equals -2, then you're going to have a slope of 0. You're going to have a slope of 0, which is pretty awesome. And then as x is bigger than this, right, when x is greater than 2, you're going to have a positive slope. And as we're getting larger and larger, our slope should get bigger and bigger, right? So when I plug in 2, I'm going to get, for x equals 2, so I'm looking right here at x equals 2, my slope is going to be positive 2. Well, what happens when x is equal to 4? When x equals 4, my slope is going to be positive 3. So as I'm getting further to the right, my slope is going to get steeper and steeper. If I choose something to the left of -2, let's choose -4 because that's easy to solve. When x equals -4, that's going to give you -2 plus 1, which is going to give you a -1. So that's another way to do it. You can always plug in values. So guys, no matter what happens, you can always choose a point and see what the slope is. Okay? So that's the conversation I'm going to have about that one. So let's look at this. So x minus y. The easiest way to do this problem is to set dy dx equal to 0. And we've had this conversation on the previous video that I can move this over and say, okay, well, the line y equals x is actually going to have slope that's going to be equal to 0. And you guys can clearly see that y equals x will have a 0. Because remember, when x and y are equal to each other, then their slope field, this dy dx, is going to be equal to 0. You can also think about the fact that, you can plug in values. So when x is greater than y, then you know the slope field is going to be positive. When y is negative and bigger than x, then it's also going to be positive. So there's a lot of things you guys can do for these problems to plug in and see what's going on. So just like in the previous example down here, if I chose, okay, well, what's happening at 1, -1, then I know this is going to be 1 minus -1. It's going to be positive 2. So at the slope at 1, -1, I'm going to have a positive slope there. So no matter what happens, you guys can always plug in and see if this actually represents what the slope field is right here. And let's just do one more. If I say let's look at -3, -1, well then we're going to do -3 minus a -1 is -2. So at the slope -3, -1, I should have a negative slope. And again, you don't have to worry necessarily about the value, you just have to worry about the sign of the slope. Now, let's look at the last example. So for this one, clearly we know it's going to be A. Actually, so let me, before I finish that, let's say, well, we know this one's going to be C. So process of elimination, we know this is going to be actually A. And so, there's lots of really cool things that you could do with this one. What happens when y equals 0? Right, when y equals 0, then dy dx is going to be undefined. Right, so when y equals 0, it's undefined. So guys, again, normally, you would see sometimes like lines like this, or most time they're going to leave them a blank. All right, so they're going to leave this blank. What happens when x equals 0? Well, when x equals 0, dy dx is going to be equal to 0. Right, it's going to be 0. And that's exactly what you see here. Well, this one really doesn't matter because this one will be undefined either way, so that really doesn't need to be there. And then what happens when they're equal to each other? So what happens when y equals x? Then your slope is going to be a -1. So y equals -x, or y equals x, you're going to see that's going to be a slope of -1, and notice these are all negative. And then what happens when one of them are opposite of each other? Let's say that x is negative and y is positive, but they're the same value. They're the same value. So what happens when y equals -x? That line, y equals -x. Well, that's going to give you the slope, y equals 1. And let's say you do all this and you still have two problems that still have all the criteria that you can see with this. Then the last thing you can do, and the easiest thing to do, is just plug in a value. So what I would do, guys, is I would say something like this. Let's look at, let's say we're trying to compare, would be a good one right here. Where would it be good? So let's say we're comparing A and D. Let's say we're comparing A and D. Let's just say hypothetically that both of these have so we did all these strategies right here, and they still have the same criteria. So they meet the same stuff. So then what you do is you look at a point on these two graphs that have separate slopes. So let's look at, this is going to have a negative value and this is going to be a positive value. And so this point is going to be 1, 2. And so if I want to go over here and say, well, let's plug in 1, 2 to this, then I'm going to get negative, x is 1, y is 2. I'm going to get a negative value. I know that my slope is going to be negative. That's going to match this, and it's not going to match that. So hopefully that makes sense, that if you go through and say, okay, well, when is y equal 0? When is x equal to 0? When are they equal to each other? And you still have two exactly the same thing, then go look at a point where they have different slopes, and this point, put that point in that differential equation and see if it gives you a positive or negative. In this case here, it gives me a negative, so I know this answer is going to be it's going to be A. So let's look at this last example. Done. So this says, example 10, which one of the following could be a graph of the solution of the differential equation whose slope field is shown below? So one of the things that's kind of drawn my eyes as you guys see this is I always like to look at where the slope is 0. So that's usually my little indicator of what's going on with our graph. So we have the slope with 0. And so I like to just kind of unofficially, but officially kind of like connect this. And this is not part of the actual solution. This is kind of telling me that this is kind of like a little brick wall right here. So something's going on right here. So like this could be like, a slant asymptote that you would normally see on the graph. So I know something is going on here. I know that my derivative of my position function has a derivative of 0 here through this entire thing. So I know that also looking at kind of the behavior, what's going on around it, that this, these are all coming straight up like this. Like just let it, like I said, this is kind of like wind. So what we're doing is no matter what we choose on this is always what's going to go on with this. So notice that for all of these examples, nothing's looking like that, right? We don't care about what's going on right here. This is the only one that you can see, but this is actually telling us that our slope should be going down. Like we should be going downwards like this. So we know this answer is not correct. And the other thing is that this, right, we know that something's going on here. We have like a slant asymptote right here. So we know that's also not going to be C. So if we look at these two problems right here, and usually, guys, the easiest way to do this is kind of like mimic and see what's going on. Well, this is at 1, 2.5, oh no, 1, 1.5. So at 1, 1.5, we're up here. We're up here, and we probably shouldn't be up here for that. Like this peak is just really way too high for us to do that. So if we look at this, let's look at something like -1/2, -1/2. So -1/2, -1/2, it looks like something right here. Well, this is telling us that we're going to start going down. Like, look at what our slope field's telling us to do. And also notice that, look at this. We have a little brick wall right here. So we know we're going to look, like that again, which both of these. But this is going to tell us to kind of follow along our path right here. So it's going to be B. It's going to be B. And the reason why, again, that we can't use A is because this peak is way too high for this problem. So you kind of even think, sometimes students are like, okay, well, let me just draw this line. This line looks very similar to the graph y equals 0. Oh, sorry, y equals x, right? So you can graph the line y equals x on your thing here, and you can kind of see that this one's going to be the best one to do it, right? And this one's actually good, this left one right here, but this part right here doesn't match with this. Okay, so this answer is going to end up being B. And there's just a lot of strategies for this. The other thing I can tell you guys about this is that you can kind of just start sketching a couple of things like I did here, right, with the purple, and just kind of see what's going on. I tend to always look at particular examples, like particular points, and see where is it starting to like have a peak right here, or what the behavior the graph is doing at a certain quadrant. Like here, this in quadrant 2, this graph is decreasing. Well, this slope field is definitely not having us decrease. Right, it's definitely having us increase. We're increasing everywhere here, right? So our slope field should always be doing this the entire time. And that's not what's happening as I see it right here as well. So, this is one of those examples that you just kind of have to play around with it a little bit and see what you guys can do with it. But yeah, so hopefully I helped a little bit with that one. And that's it. So hopefully this makes sense to you guys, and we'll come back in our next video when we do more BC Calculus.